In this video, I will be explaining DNA fingerprinting with gel electrophoresis. But first, let me explain what gel electrophoresis is and how it works. DNA is placed in the wells at the top of the gel matrix, where there is a negative charge. DNA fragments then move downward to the positively charged side of the gel matrix. Because DNA is negatively charged, it will naturally travel down toward the positively charged side. The further down the DNA reaches in the gel, the shorter the fragments will be and the faster they will travel. On the other hand, the closer the fragments are to the top, the longer the DNA is and the slower they will travel. Forensic scientists are able to identify criminals based on their unique DNA fragments once they amplify various VNTR loci. Here's an example of a case where DNA fingerprinting is useful for catching the correct suspect. There's a victim, Cade, and 4 suspects, Penny, Moose, Charlie, and Nessie. All of these pups were at Cade's birthday party when Cade was about to enjoy his birthday cake. He turned around to see a bird chirping in the distance. When he turned back around, the entire cake was gone. But who could have taken his cake? Under closer investigation, there was a hair found on the crime scene. Forensic scientists amplified for 2 different VNTR loci off of the hair, and each pup at the party was considered a suspect. Let's look at the first VNTR loci. All of the bands must match the bands from the evidence. Starting with the victim, we can see that both the bands match the evidence. Suspect 1 doesn't match either of the bands, meaning that Penny could not have been the thief, because the real criminal must match both bands at both loci. Moose only has 1 band that is the same, but 1 that is different, taking Moose out of the suspect pool. Our next suspect, Charlie, also doesn't have any bands that match the evidence, meaning that he could not have stolen the cake. Lastly, Nessie matches both of the bands from the evidence, making Nessie the possible criminal. Now on to the next locus. Here, the victim doesn't match any of the bands from the evidence, meaning that Cade did not eat his own cake. Suspect 1 matches with one of the bands, but not the other, and because Penny did not match the bands at locus 1, Penny could not have eaten the cake. Suspect 2 does match all of the bands at this locus, but does not match all of the bands in the first locus, meaning that Moose was not the criminal. Suspect 3 doesn't match any of the bands, which makes Charlie innocent. Suspect 4 matches all of the bands from the evidence in both loci, making Nessie the cake thief. While doing the investigation, the scientists saw that Penny and Charlie looked very similar and wanted to know if they were related. We know that parents and children must share at least 1 band at each loci in order to be related. Look at the loci of Penny and Charlie. We can see that they both share 1 band at each locus, making Charlie the father of Penny. Thanks for watching.